today we are here to talk about something in particular. Of course, you can branch out to many other topics, but this week we release an article that we think is very important to set the tone of what you're doing and make it very clear for the Web3 community, for developers and researchers, the contribution that Cartesi is bringing to the ecosystem, right? So we wrote an article that we called our rollups thesis. And today we want to just have this free conversation and talk about the topics and the aspects of this article here.
Yeah.
So maybe you, Felipe, you can give an outline, a TLDR,
Sure. Yeah.
for ourselves to start the conversation.
So it feels like the article was coming up of the ideas that we've been discussing for a long time, and we finally finalized it, right? And outlined. So I really like it. Actually, I'm proud of it. I feel like there's so much more to say. We try to just keep the main ideas there, but on each idea we can branch out and actually go write many more articles. So the outline of the article is basically we start by talking about the state of the blockchain, the problems that blockchains are facing, and how all the projects, right? There's so many cool projects. They're targeting their place in the environment and in the design space. What we think are the good design choices. So how to fix, how do we see the way to fix those problems that we talk about not only the EVM, but also how somehow the problems of EVMs are also being inherited to some rollup designs, and how we can do stuff differently now that we're on layer 2, right? So we're not forced to only do the stuff that we're already doing, but we can also explore bigger design spaces. So we also discussed on what are those design spaces, what are the other options we have. Of course, all the options have their trade-offs, but we chose a path and we're very excited about it.
Yeah, in particular, we talk about our fundamental design choice, about getting into optimistic rollups with interactive dispute resolutions, and I think that's very important for us to explain why we made that choice. And we explain why rollups and why we want to scale computation at a moment that Ethereum is focusing more and more on making data availability cheaper. And we also want to talk toward the end more about the resources developers have to build smart contracts and our very particular view on this, right? So I think, how about we start talking about the problems that we see or the insufficiency that we see today in the blockchain space, in Ethereum and beyond, of course. And from there we can talk more about Cartesi. Who wants to start?
No, I can start if you want. So I think a big problem I see, at least in Ethereum, is that the EVM, it's a novel machine. And the issue of it being novel is that you cannot run any sort of stuff that we already have into the EVM. So we have this constellation of ecosystems such as compilers and programming languages and libraries and operating systems and databases and so on. And none of that can run on the EVM. The EVM is quite novel, So we need this time to actually create content for it. Or we could try to design a virtual machine which is closer to the computers that we use every day. So I think that's one of the insights that we brought into the ecosystem. So I see this programmability as one of the biggest issues of the EVM, especially when we start to scale out computation.
Yeah, it was a bottleneck, right?
Exactly, because this is a problem that gets revealed once you explode the computational power. Yeah. So for example, we wanted to, zipify. Then there are many algorithms, none of them have an implementation for the EVM, but that doesn't matter because you cannot run a compression algorithm on Ethereum, it's too expensive. But as soon as you break this constraint, then you could be able to compress something, but then you have no implementations.
Yeah.
So I see this as one of a big pain point of the EVM.
Yeah, I agree. There's also a security facet to it, right? The security side, which is something so important in the industry, because every decentralized application, in a sense, that exists in an adversarial world, where it's very hard to patch things and update things because no one controls the code base. So the security becomes a huge issue.
Yeah.
And when you have to rebuild all the software that you need, so you're building an application, and instead of focusing on building that application, solving the already hard problems that you have to solve when you're building an application, you have to spend like your brain power
Yeah.
creating all the tools around it and building like the mathematical functions that you need. And like
the cryptography function.
yeah,
And then there is an issue. No? Would you trust something that is out there for like 20 years and everybody uses, or something that you just wrote yourself?
yeah,
So how safe is that, right?
Yeah.
exactly.
Yeah, so there's a safety issue, right? So if you think about it, in EVM, we had to develop a full compiler to target it, the Solidity compiler. And the question is, would you trust more the Solidity compiler that like we've made it in a few years, like very ad hoc, or GCC that already exists for a long time? So we have this like security, let's say, facet to it that we can also patch.
Yeah, even for writing simple code,
Yeah,
it's better to write simple code with battle-tested software
exactly.
than to write simple code with
Yeah.
something else.
So if you allow me to just try to summarize, because I think we're talking about many different aspects of our view on blockchain tech and what you're doing. So you guys are talking about the resources developers have to create these smart contracts, talking about the security aspects of using the existing languages and virtual machines for blockchains. But there's a third aspect that we want to also explore here, which is the computational scalability in itself,
Yeah.
right? And perhaps I'd like to go deeper into this aspect first, because then it will clear later how we can advance into a AVM that would support something beyond the standard EVM that we have nowadays, and then we can justify better these design choices.
That's a great point actually, right? Because the computational limitations is what stopped us from exploring this design space.
Yeah.
So maybe we should actually talk about that.
That makes sense, yeah.
And the way that I see it is that because blockchains have these very tight computational and data availability resources, it was not even possible to imagine using mainstream stacks or booting an operating system on chain.
Yeah.
Things wouldn't fit in the block, right? In the blocks. So I think we all in the industry became used to this paradigm in which you have a VM that's restrictive.
Yeah.
And what we're trying to propose here is something different. By the time we're able to really scale computation orders of magnitude, then we can rethink this approach and have more expressive tool sets and other VMs that will allow much more to developers.
Yeah, I think it's actually an insight that the industry kind of had together, which is like this insight of specialization and delegation, right? So we figure out what are the aspects of a rollups application, for instance, or like a decentralized architecture. And we're now having projects that are focusing on improving one aspect. So the common example is the Ethereum rollup-centric roadmap, right? Which is basically Ethereum saying like, okay, let me do data. I'll do data very well. I'll provide data availability, and I'll delegate to all these other projects to fix the scaling computation. So now we have this very interesting, which we'll also talk about in the thesis. This very interesting aspect that we'll have very soon a lot of data coming, and we now have the ability to create execution environments that are expressive enough and powerful enough to not only build better applications, but also applications that deal with a better data source. So I feel like by specializing and by delegating, we can start to like improve significantly the kinds of applications that we can create, right?
Yeah.
And I don't know if you want to talk about like how we are planning to scale or how we are
I
scaling.
think that's an interesting conversation for us to have in the first half of this discussion, right? Let's talk about the computational aspect of scalability, how current rollups are dealing with this, and what we see and what we're proposing.
Yeah, so one of these approaches that was the first one to come out is this in which you have this separation. So layer 1 takes care of data availability and all that, and then computation is on a layer 2, but it's replicating the same paradigm, right? So it's an EVM, all applications run on the same rollup, and this has given a boost, right, in throughput, where you can compress the inputs and all. But the feeling is that over time, they are still all of the applications, they are competing for the same resources, right? So they're competing for the same processing power, the same data, same
Block space.
block space,
Block
yeah,
space.
yes,
Yeah.
CPU and all that, the memory. And so it will eventually get gentrified,
Yes.
right? So that's inevitable. And if you want to
Yes.
scale that to the entire world, inevitably you have to find scalability in another way.
And I,
Yeah, because that's the point, right? We like essentially copy what's going on the
Yeah.
And if you are like a very popular application like Uniswap or something that gets like already gets a big share of the block space, then maybe you're fine with the way things are. But if you're like some tiny application, some fun game, or something that can't really outcompete Uniswap, like for block space, like bidding block space, then that design maybe is one of gentrification. So you really lose this sovereignty over your own space,
Yeah.
and that is something I think we are addressing.
and I'd like to just linger a little bit longer in this because I think we can unpack this a bit further.
Yeah.
That if you are developing an application, it's very insecure. It's an insecure situation for you as a developer. Okay, you are developing something that today, for the current gas fees in your rollup, it's gonna work. You think your users will be able to pay for transactions because they are cost effective, they're cheap. But in the future, who knows? Maybe 1 year down the line, your rollup chain will be full of applications and will have some DeFi's. Things start to get gentrified.
Yeah.
The fees will start to get higher and higher. And your game cannot be used anymore or application because your users are not willing to pay for higher fees, right? So these elements of unpredictability is really bad for developers.
Yeah.
And for users alike.
And for users alike.
The massive UX improve, the predictability. Yeah.
So we go.
So just like one tiny comment. It's not even only not popular applications that can compete for block space. It's highly financialized applications.
Yeah.
So it may be not even popular, it's just people that can afford
Exactly.
the block space.
People who are willing to pay a lot of money, and that's
exactly.
financial implications.
And I'd argue that if we want to have an international system,
Yeah.
a system that is inclusive, allows for all kinds of different applications, and to actually like fix human problems.
Yeah, to really be fair,
Exactly. You cannot like $5 a transaction is already a lot of money for other people, and we've gotten way over that for some period of time, right? So
And I think all this problem stems from the fact that current rollups, the EVM-based rollups, normally they repeat this paradigm that Milton was mentioning before. They work like computational shards in which more and more applications start to share the same CPU, the same block space, and eventually things get gentrified. And so that I think this aspect of inclusion or exclusion is very important because we are in blockchain, and there is an ethos of inclusion. So
an ethos of cooperation,
Of cooperation,
fairness.
yeah.
And if we are excluding people who cannot pay for those high gas fees, we are like the purpose of it is to be permissionless, but it's
with a high financial price.
exactly
Permissionless
then it's,
with the price.
it's permissioned.
If you're rich.
If you're rich, yeah.
But I think it's not only about gas prices. It's also about increasing the power of applications by themselves. Which of course it's related because if you have the entire block space, say, to yourself, then you can build more powerful applications. You can explore different financial models and different business models. It's a wider range of applications that become possible. And I'm so excited about that, I'm so excited about it.
Exactly. So like if we see the ecosystem, it was shaped by the lack of resources. So what you're saying is that now that we are allowing this, giving more resources, it's going to completely change the landscape.
Exactly,
I need to put some wood on the fire.
Oh, please, it's getting cold.
It's getting cold here.
So this shift we're in the article we're referring to that shift, the shift from global consensus to app chain rollups. Global consensus being everyone verifies everything. App chain rollups being there are some things that should be globally verified, There's a base layer, settlement layer that has consensus and then has strong community watching over it. And then you can move your application to the app chain rollups, which shouldn't be confused with app chains in the sense of side chains. Because while they sometimes use the same arguments of having all the block space for the application and having customizability and so on, they have a challenge which is fragmentation of validation, right? So if you have your own side chain that doesn't inherit security from the base layer, then you have that problem of having to have a majority of honest nodes and so on. So that's why we try to be careful using app chain rollups, which are what we mean is we share a data layer, we have their own validators for the rollup chain, but on that design that I imagine most people listening to us already know about, which is fault proofs. We need one validator out of everyone watching the app. We don't count on the majority. We need only one person. So that's how we get over the fragmentation of validation that app chains in the side chains have. So yeah.
And it's very interesting because we see this trend that some developers are looking for app chains, be it like sovereign chains or exclusive rollup chains. And you saw that, for instance, in UI, UX, they did this move to have their own blockchain because they wanted to customize the experience for the users. They wanted to remove the fees from market makers. And how can you do that on a base layer that's shared by everyone with the same rules, right? And you see this need for more and more applications developers to have this customization and higher scalability. The good thing about what we're proposing about app chains at the rollup stage is that you can actually allow for this kind of customization. You can tap into much more computation, and at the same time you inherit the strong security guarantees of the base layer, and you can have secure bridges across different applications as well. Right? So it seems to me to be like the union of two very good realities.
And I think that's one thing that's very interesting. That again, the industry as a whole is coming to a conclusion together. Is that we are now separating how blockchain itself works in different layers, right? So already the separation of the data with the computational aspect. And now with this separation, we are also seeing the idea of a execution layer, which as you are customizing for each application-specific rollups, you can have different execution environments. And that opens the door for a lot more of innovation.
So expanding on something you said about, we get this full block space for every application. And you said that we have these meta parameters that we can tune per application. So you can choose, for example, the consensus you'd like to use and which validators you'd like to use, which could even be permissionless. Or you could, for example, stay in a different side of the trilemma. You could say, oh, I want more scalability, or I want more security, and then you can tune those parameters.
Or perhaps I want to optimize to be GDPR compliant, and I want only nodes running in Europe.
Yeah, exactly. That's a very good point.
It's all about UX as well, right? Like it's not only security, it's not only scalability, but it's also all these come together to provide a better experience for both the apps, but also the users and the developers. So,
Is there something that we want to explore in the conversation about modularity, the trends that we see around the separation of layers, as Nick was saying? We see that in Celeste, we see that on Ethereum. I think we can explore this topic a bit further.
Yeah, for sure. I think like it's in hindsight, it's almost obvious once you have always is. Once you have a bunch of different smart people focusing on improving very much one part of the problem, and then you're composing the solution, they all work with each other to be great, right? So now it's amazing because before one team was trying to solve a massive problem. Now I have a bunch of teams trying to solve still very challenging problems, but smaller ones. And all these different solutions, they can compose together in different setups depending on the application, depending on the profile of the users, or the profile of the developers. And it's just so much better to like, okay guys, let's focus, let's build the best execution environment possible. and let's cooperate and collaborate with all these other projects that are
Yeah.
like increasing data by orders of magnitude. I don't even know how they can do that,
Yeah.
but like, very smart people working on a very hard problem instead of very smart people working in parallel in 10 different very hard problems.
Yeah,
Right?
exactly.
So
It has a bit to do with the subtraction concept, right, that we saw being presented on that one.
yeah,
That's a very powerful concept.
It
That each project or each team can collaborate by bringing something that they do very well,
Yeah.
and finding the links with the other projects and the whole ecosystem
Yeah.
gains.
And having this more modular approach, we can, so for example, one execution environment can be very good for certain kind of applications, and the different one can be good for other kinds of applications. You know, so for example, the DVM, it is good for certain kinds for a class of applications, and we offer a different execution environment which addresses a different class of applications. So this subtraction and modularization also allows us to optimize for the specific use cases.
Yes, yes.
and it's easier to know what we're actually building. Like, other teams, I feel like they're now focusing on one problem. They can understand that problem
Yeah.
quite well, and they can tailor made their like. I think it's a very powerful concept, and I think we haven't yet seen the like bubbling up
Yeah.
of all these solutions coming together.
Mhm.
And I'm really excited again. I keep saying that, but I'm really excited to see what kind of applications, kind of powerful things we're gonna be able to build
Yeah.
once these all like comes together.
And also still related to modularity, I think one of the things that I like to see is this move that some layer ones like Ethereum and Celestia are doing to really focus on data availability and to let rollups projects take care of computation, the separation of responsibilities. And in the article, we talk about a concept that we fell in love with, about this cone of innovation. And I think we could talk a little bit about this concept here, right? So while layer ones are focusing more and more on data availability, you can think that data is going to be cheaper, then you can have applications with more data throughput as well. And meanwhile, rollups are providing better and better computation for applications. So you can think of two axes in which data gets cheaper, computation gets cheaper, and more things can be done as things get better across these two dimensions, right? So, what do you think of this concept?
Yeah, it's very cool because it makes it more understandable that as much as you can improve data scalability, if your computational capacity doesn't improve that much, then, for instance, you can have a lot of data coming in from IoT sensors or from data coming from outside, but you don't have the computational capacity to analyze it. So the interesting thing about this cone is that there are certain parts of the possibilities of these two dimensions in which you simply cannot do much because you have a lot of data, but you can't process it. So there's not much to be done with all that data. And the same happens the other way around. So
It's like you have a calculator, very simple calculator, but then you have terabytes of storage. What to do?
yeah, and if you have like this
A lot of
all this computational capacity, which is what was the situation that we were in, like before this rollup centric roadmap and before the folks started really scaling up data, we had this powerful VM that we could compute a lot of things, but there's simply almost just few bytes coming in. So the diversity of application that you could do to build on top of that also weren't exactly all the things that you could explore if you have both a lot of data and both a lot of computational power.
Yeah, I like on the cone of innovation, the graph that we have, we can see a lot of what we're discussing here, right? But you can see the different projects that are working on computational scalability, increasing on the graph of computational scalability on the axis. And you can see like it's a composition of different projects, right? So I have like app chain with app chain rollups with EIP 4844 that the Optimus guys are doing, right? And then you can see like how much that opened up in the design space for applications. And I think it's a very like visually didactic, like it's very good to explain
Yes.
how we see the the future of decentralized applications.
Yes, and that makes me think that we are really at the beginning of this phenomenon of decentralized applications. So with monolithic chains like Ethereum that get gentrified, you cannot do much. Look at what you can do nowadays. There is maybe perhaps one exchange that people can use and not much else. Perhaps some ICOs or NFT sales when people are really willing to pay to enter bidding wars, paying $1,000 to be able to buy the NFT before the other person. But so if you look at the origin of this graph, where computation is expensive, data is super expensive, which is the case of Ethereum as a monolithic chain, then you cannot do much. You can do gentrified DEX, and you can do token sales. And as you start to, as things start to get better in these two dimensions, more and more things become possible. You can think of, I don't know, GameFi or some games or some DeFi that's more inclusive, that more people can use. And but still, what we have today in terms of DeFi and NFTs is only the beginning. You can imagine how many more things can we do in the future when we go beyond these limitations of data and computation. And that's the part that mostly interests us. We can talk more about that.
Yeah, just one thing that I'd like to add. You cannot do much, right, on Ethereum monolithic Ethereum. But what you can do on Ethereum is fantastic because it can become the settlement layer. You can hook all the other rollups, at-specific rollups on that logic, which only needs to do a proof validation or something like that. But the logic that you can put there is essential for the rest of the things to be able to
Yes, the most secure place, most watched place, right? That manages the communication and secures the assets and so on. But one thing that I feel like I would love to add to the cone of innovation, actually two different axes that I think visually hard to include, but it would be interesting. One of them is privacy, because I feel like the privacy angle also opens up a wide array of applications. And privacy is something that is very valued in a lot of different places in the world. Because if you live in a dangerous city, then having your financial activity out in the open might be dangerous. And the other one is the programmability aspect. Because when we were talking about this beginning of the graph, we said Uniswap, for instance. It's an amazing the app. It works great. But Uniswap had to optimize to minimize number of interactions on chain, right? Had to optimize to solve all these hard constraints that are there because of the lack of data scalability and lack of computational scalability.
Mm-hmm.
So they wrote awesome code, but they didn't write the best code to create an exchange, a decentralized exchange. They wrote the best code to create a decentralized exchange under those constraints.
Yeah. Mm-hmm. They didn't write the code they wanted to write.
Exactly, that's a very good way to put it. Yeah. So I would love to include privacy and programmability.
Yes.
Yeah.
So in other words, could you say that applications, when they live in these constrained environments, they are optimized for something that's not what their business really needs?
It's not the core of
Not the
their
core.
business,
Right? So if you take away all the complexity of Uniswap regarding gas optimization, auditability, you know what? You are left with very simple building blocks and features.
Yeah.
When you compare these features with what you have on mainstream on Web 2, for instance.
Exactly.
I think maybe that gives us some hope to the next
Uh-huh.
part that we want to talk more about programmability.
Yeah.
Because I think just like high computational costs and high data costs create a better experience for developers, they have to be very skillful to create these applications in this environment. Now, let's talk a little bit about tools, about the VM, the shortcomings of the EVM, and what we're offering. Maybe who wants to give the kickstart?
Yeah, I think Coutinho already said a little bit about this. So when you're developing software, the fact that you cannot use a ton of libraries and resources that are out there, and not only that, but even if you want to implement them, there are many restrictions. You can't make a loop that's too long, or you can't do string parsing. So that kind of thing, what happens for most developers, especially those coming from the mainstream industry, is that whenever there's a problem, right, they want to build an app to solve a problem, to give some service, and the way that they want to solve it, they have to always stop in the wall. No, this won't work. This is restricted. I can't go there. I can't use that algorithm. I have to find it somewhere else. I have to do research to invent a new algorithm and then implement it from scratch. So I guess that's the kind of thing that a different paradigm could allow these things to flow, right?
We can give the example of topology implementing on Starkware.
That's
And they had to build from scratch a whole logic to deal with physics, with gravitational fields, or things that already exist for decades as open source, available a few clicks away on GitHub. People had to spend most of their efforts re-implementing from scratch, reinventing the wheel. I think that's a good example.
And it was admirable work, really, really great work.
But that excludes
The average developer.
Yeah.
In the article, we even say that we're sure that the Angry Birds developer didn't have to implement those libraries from scratch. Even though, as we say in the thesis, the laws of physics are the same. Like shooting birds or.
So there's this quote of Carl Sagan. It says, if you want to create an apple pie from scratch, you'd have to invent the universe. And I think this kind of has to do with what we do, right? So bakers, it's quite impractical to recreate the universe. So bakers usually use a pre-existing universe, and we programmers do the same, And by starting from the EVM, it seems that we are on this microcosm, this new universe, where we have to create those tools from scratch, tools that already exist here, but do not exist there. So the insight, I guess, is not like let's rebuild everything. It is more like let's bridge what already exists into that world.
You can even use the term let's compose with all the software that's already being built.
Exactly,
Yes. So I find very peculiar this severance that you see in Web3 with all the history of computer science in that sense. That you cannot rely on abstraction like you do on Web2 and on mainstream programming.
In a sense, I think that comes from the constraints again, right? So it comes from us trying to build this world computer, which cannot be too powerful, because if it's too powerful, then you exclude part of the world, but then ends up excluding part of the world anyway, because then the world fights over this small computer.
So the question here is then, I think that's a very, very, very interesting angle, because the question then is, okay, the EVM was born in a context of where all these limitations were there. Now that we're able to scale things much more, shouldn't we rethink virtual machines for blockchains?
Exactly.
Right? And that's what we're doing here. We're proposing a VM that you can use and can boot a real operating system, and then you can have access to all these components.
So the opening up of the design space, right? I mean, EVM might be still good for some stuff.
Yes.
No, EVM is the one in the base layer, right? It's
for
great. It was designed and it works great for exactly being that settlement layer where you have the basic logic, which is what it was designed for.
The communication protocol almost.
Yes, so it's a foundation, right? But then if you're doing something on top of that, you don't need to inherit the same mindset, which was geared towards a very
domain specific.
domain specific. Yeah, it's something that would not scale because you want the whole world to replicate it. So it doesn't make sense to scale that way. So it was made for that. And if we are now doing application specific things and scaling, we should rethink if we should really use it, the same thing. But it's kind of natural that the first movement was to go there, right? Because then, if it was, you can scale what we had before, and it will work the same way. So it's completely natural for me, and makes sense that we had EVM compatible rollup solutions. Great. But we should think about other things because the design space is now much wider.
Yeah.
And again, we come back to the aspect of inclusion. The moment that you offer mainstream tools and languages and libraries and components to smart contract developers, then you include a much broader range of developers.
Feed the fire.
Fine.
Yeah. There's this one idea that I think we often when we frame the problem as, okay, now you don't have to re-implement, I don't know, a logarithm function.
Yeah.
Yeah.
It's gonna be better now, I think.
Right. You don't have to re-implement a logarithm function or a sorting algorithm and so on.
Mhm.
Is that it's not just like effort, you know. It's like we can, if you're a specialist, I won't be able to do what you do better than you do. So, for example, I wouldn't be able to implement the sort algorithm in the Rust standard library better than the programmers who did it. You know, it's just not possible. So we are leveraging knowledge that we don't hold ourselves to build new applications. So I think
So that's the essence of computer science.
it is.
That's the
It's
essence
essence of abstraction.
And many other things in the world.
Yeah.
It's already hard enough to build that you want to build.
Yeah.
Yeah.
It's already hard enough to build
Yes.
the next change with all the tools that you have on mainstream.
And then you have to deal with very little data, very little computation, and
Yeah.
very little
Yeah.
tools.
Exactly.
So the guys are heroes, right? The guys
Yes.
that are doing.
They are.
But we want to include non-heroes in the blockchain space.
No, we want to include heroes that can really focus on what they want and need to focus on.
Yeah.
True, yeah.
And
We don't want
a
people to
lot
keep
more-
reinventing the wheel all the time.
Yeah.
It's a lot more efficient, and in the end, the service, and if this is all to provide public goods and public services to everybody,
Yeah.
the efficiency of doing that is important.
Yeah.
I mean, if you keep spending all your energy rebuilding things,
And including more people also increases the kind of public goods
yeah,
Yes.
and the diversity.
and the diversity, right?
Yeah,
Because people like, if you exclude people from unprivileged places, for instance, then it's very hard to solve their problems. They cannot express what problems they have if they're not included in the ecosystem as a whole.
Mhm.
So increasing the design space, increasing the amount of people that can understand the tech and work with the tech, also helps us create what we actually need to create, which is a comprehensive
Yes.
comprehensive array of public goods
Yeah.
that serve like everyone, right?
yeah, and one aspect of that is that we've been hearing from mainstream developers for a while already that they are very interested in Web3, very keen to start doing something, but all their skill sets are worthless. So they kind of need to relearn or learn new things.
And it's a big risk to jump over.
It's kind of a risk, and it's a barrier, and actually they don't feel capable of contributing. So we're the ability to include all these people is demographic. So you have a lot more of innovation to go.
It's interesting that we pass through many aspects of inclusion.
Yeah.
Yes.
But I think that's what blockchain tech is all
Yes.
about, right?
Yes. Okay, I think we covered almost everything. Or is there anything else you want to cover? We want to talk a little bit about the why we chose interactive dispute resolutions, for instance.
But also that might be a little bit too technical, but in our eyes, it's the design that allows for the biggest gain in computation scalability. And I guess, as we were saying, each protocol is specializing in one thing, and we want to specialize in that because we think that's a very important thing. And then that ties into all of the other things that we've been discussing here, right?
Yeah, I think it ties in with the idea that it's basically about collaborations between all the projects, because this kind of decision that we are making is to make it possible to build applications that take advantage of all this computational scalability and all this programmability scalability. But then there are other applications there that maybe would benefit from other features. So I think the beauty of this design space that's opening up where you can have different rollups with different design choices geared toward different
Yes.
objectives. So you can have ZK rollups focusing on certain kind of applications, but then if the computation required for that particular application is too complex, then it starts to take too long to build a proof of not being cost effective. So depending on what is adapted you're building, what the service is providing, one solution can make sense or the other.
Indeed.
Yeah.
Very good.
Yeah.
Do you guys feel that we're coming to an end, or any
Now this
final?
is just the beginning.
This is
Yeah, that's just the end of this particular talk. But I'm sure it's more the beginning, or the end of the beginning.
Yeah, I think it is a good note to end. I feel like we could be talking for hours and hours, as we do remotely quite often.
we could really like nerd out on very technical aspects. And I think on a high level, this is.
I think we covered everything that we talk about in the thesis.
Yes, I think it's also worth saying that we are all very very open to have this conversation publicly with other projects, other developers.
Yeah.
Right? We're really willing to engage and exchange ideas and know what people think about it.
Exactly, because in the end we are making a public good, we are providing to the community as the other projects are doing.
Yeah.
I think it's exciting times of kind of a convergence with all this idea of modularity and what are the modules and how they connect to each other. It makes it a lot easier for everybody to share what they have been building and to connect with each other, because now that we are kind of speaking the same language, we know how to fit all the pieces, So I think it's convergence, I guess, the thing that comes to mind.
Being here in DevCon is so exciting,
After
right?
3 years, right?
Yeah, and we see like all these other projects and all these people, and just like it feeds the fire in the heart, right?
Yes.
And what I'm so excited about this space as a whole, and I'm so excited about what we're doing as well. So,
Yeah, we all are.
so yeah.
Thanks for this great conversation.